into x to the power of 4, it's x to the power of 3, I think. So we get x to the power of 3 up here. And then if we had long division like this, I know I did this on the other video, so I won't do it again, you can watch that. We can multiply both these to find out what our remainder would be. So maybe I will do it because it's a bit easier. If we have 14 into that, 14 fits into 62 how many times? 5 times? 4 times? 4 times, okay. How do I get what my remainder is? I can do 4 times 14. 40, is it 56? And I calculate my remainder by subtraction here. So that will add on to this bit. So we might as well just do this. This will give 6, and then the 4 will come down, and we continue on. Now 14. We're going to do the exact same here. We're going to do, what's this multiplied by this? So I'll get x4, which I wanted, plus 2x cubed. And I'm going to subtract it. But I'll have to subtract both bits. So I change the sign here from a plus to a negative. This will cancel out. This gives minus 5x cubed. What did I do here? Well, I needed the next bit of the number to see how it fitted into the next part. So I'm going to bring down minus 0x squared. So that's going to come down the same way this 4 came down here. To create the next part of the number.
Wait, for that one you just brought it down. For this one you add on.
Is one number though.
Oh no, never mind.
This is like, this. We could split up into 60 plus 4. Yeah, that's what they're doing over here.
Oh.
The same thing. It's the same thing. Okay, I'm going to remove this example because we're not using it anymore. Wait, I'll leave it up if you want. But I'm focused on this now. It's a reset. I think, right, that's one done. I'm going to do the next one now, the same process. X times what gives this number now? So x times minus 5x squared gives that number. I check by multiplying down. I get minus 5x cubed minus 10x squared. Draw a line underneath. I need to subtract again. So everything needs to change sign. So that becomes a plus. That becomes a plus. So I'm subtracting here. That cancels out. I wanted that to happen. And I have a 10x squared. Bring the x down. Start the process again. X times what gives 10x squared? It's 10x. This depends on its last legs. Right, multiply both. So I get 10x squared plus 20x. What do? I need to subtract to find the remainder. This becomes minus. We get minus 19x. Bring down the 4, and now we're at the last stage. It's minus 19. I knew that. Minus 19 times this gives minus 19x. Minus 19 times this gives minus 38. Draw a line underneath. We're going to subtract, so this changes to plus, plus, change sign, 34. I've answered the question. The remainder is 34. Now the question is there a faster way to get that remainder?
No.
Yes. Yes, there is. I'm going to sub something in.
Wait, what's the point of learning that then?
Yeah.
Yeah.
Wait, you just made us do all that
Yeah.
homework?
No.
Because,
Factory.
is there a faster way of getting the remainder? Yes. Is there a faster way of getting this? No. Okay, so how can I get the remainder faster? Well, I know x plus 2 is a factor of what?
Can't you just do x? Oh, no.
So when we have factors in quadratics, so we have a quadratic.
It does.
Wait,
How is he right?
Okay, 19 minus 19 plus, okay. All right. So when I have these two, yeah? Isn't that this kind of the statement that x plus 2 divided into x squared plus 5x plus 6 would give me x plus 3? Do we see that would happen?
Yeah.
Should happen. These two multiply to give this, so if I divide this by that, I should get that with no remainder. Okay? So, but we know that these are kind of solutions to the equation. That we can say that x minus 2 and x minus 3 are zeros to the equation, yeah? If I substitute them in, I get what?
0.
I get 0 when they work out. Right.
But you can't divide something.
Hmm?
You can't divide something by 0. Okay, yeah. No.
Okay, yeah. All right.
Oh.
Okay. Let's look at then what happens when I say, well, this, we had the same thing here, x plus 2 divided into this gives that, but we had a remainder. What will the remainder always be linked to? Which one of these terms is the remainder linked to? The last one, the constant, yeah. It's always linked to the constant. Because the x squareds and the x's have been all taken care of. So, watch what happens when I do this same thing. X plus 2, when I do the null factor law, I get x equals minus 2 is a solution to this. It's a 0. Should make 0 if it is a full factor. What happens if I just sub it in? If I just sub in minus 2, so I get minus 2 to the power of 4, minus 3 times minus 2 to the power of 3, minus 2, minus 4. What answer do I get here?
0.
Whoa.
Are we sure you're going to get 0?
Shouldn't it?
Okay, 16.
No, because you're getting remainders.
How about 16 here? That's 8. 8 times 3 minus 24. Minus minus 2 is plus 2 minus 4.
That's plus 24.
It's minus.
Sorry, it's plus 24. My bad, that's my mistake. Because that's minus 8 and that's minus 3. I forgot about that. That's definitely not given 0. What number is it given though? 38?
38. Gives us 38. It's
Oh, it should give 34.
Sorry, did we do something?
Oh, we made a mistake.
we got 38.
Yeah.
What's the mistake?
Wait, what are those factors?
Oh, it's minus 2, isn't it? Not plus 2? Because it's plus x. Why are we doing minus x?
It's plus x. Yeah. Alex found the mistake. That's better.
34.
Now it's 34. Now it's 34. The same remainder. So what we really are is skipping right from doing all this to getting the remainder by just subbing in minus 2 and seeing what's left over. So you can get the remainder. You won't get the rest. You won't get this. You can get the remainder of the division by just substituting in because of the null factor law. You get the remainder.
So
Maybe.
Is that like a constant? No. Because in this one.
Okay, so when I subbed in, if I had my previous question, or not a question, example, if I subbed in minus 2 or minus 3 into this, I'll get 0 as my remainder because it fits in perfectly. But if I subbed in, all right, well, let's say x plus 1 is I want to find out what the remainder is here. I could just sub in minus 1 and it'll give me the remainder. What's the remainder going to be? If I divide this, I don't have to do out the full thing, but I can get the remainder by just subbing in minus 1. So that's 1 minus 5 plus 6 is 2. So I know the remainder is 2. Okay. Let's do another question. Let's see what we can do with that. So I know that the short way to find the remainder is just to substitute in. I don't need to do the full division. I can substitute in and see what's left over with the division. What about this second question? Find k given that x minus 2 is a factor of this thing, x cubed plus kx squared minus 3x plus 6 is a factor of that, and then hence fully factorized. So I have to find k first. If I know something is a factor, do I have to do a long division? If it says it is a factor?
No.
No. when I use the null factor law, what can I substitute in here that I know will give an answer of 0? 2.
But it's saying hence fully factorized.
Yeah, afterwards I'm going to fully factorize.
Well, isn't it easier to fully factorize first than factorize?
There's k here. I'm going to factorize it if I don't know what k is.
Oh. No, sorry.
Right, so my idea is to sub in 2, because I know that if I sub in 2, knowing the null factor law, x equals 2 is a solution or is 0 to this equation, so I'll sub in 2, I'll get this. And I can safely say that that's equal to 0, because when I sub it in, and that'll give me an answer for k straight away, yeah? Well, maybe not straight away, but we'll get there. What's k? Quick maths. Negative 2, yeah.
Quick maths.
Oh, that is
K is negative 2.
so much easier than what we did.
Okay, so yeah, that's what I'm saying. For your homework, you were kind of stuck on this. You didn't.
Yeah.
You had to go different methods. You had to find, okay, what was the quadratic that would multiply to give. You could have used this.
Oh, wow.
You
And you
just
didn't
want-
want
No,
to
I didn't.
tell
I wanted to
us
just
before.
suffer. That's why it was a bit of a synthetic question, as I say. You would have more information to do this in the exam. Therefore, it'll never come up in the exam where they force you. Anyway, now that I know k is 2, what's my next step? I now know x minus 2 is a factor of the full equation. What's my next step? It's minus 2x squared minus 3x plus 6.
AX, right? Oh, I know, we just do long division.
Yeah.
Or would that take too long?
Okay, we definitely can, yeah.
Or no.
Oh.
Enlighten us out.
All right, you do long division. I did one already. It's your turn. Do long division. What are we expecting to get? We're expecting to get a quadratic like you had for homework. Once you get a quadratic, you can factorize it.
Wait, I just realized you said this helps us with the remainder. That's not the remainder, that's just another factor.
So I'll give you a hint. The title of the lesson is Remainder Theorem and Factor Theorem. The first question we did used the remainder theorem. The second question we're doing is going to use factor theorem. But you divide.
Oh, factors.
You divide. Divide, get your long quadratic answer.
What's the point of learning the equating coefficients
It is a useful skill. It is a useful skill.
then? 4?
Your logical brain training.
Oh, come on.
Come off it.
Wait, but the
Yes, I
remainder,
really trained my logic.
so
Ha, yeah.
the remainder theorem is the one on the right, right?
Yeah. So you're not using the remainder theorem anymore because you know that it fits in perfectly. There is no remainder.
I know, but with the remainder theorem, after you finish that question, you said there's not an easier way to get the ending.
Oh, you ask me, is there an easier way to get this answer? I'm not saying.
No, an easier way to get the remainder.
Yeah, the easiest way to get the remainder is to sub in for x, yeah. It's the easiest way to get it's not the easiest way to divide because that doesn't give an answer for division.
Wait, how does the long division work? Because you're just dividing everything by 0.
Ooh. No. You're not dividing everything by 0, you're dividing everything by x minus 2.
Yeah, but if x is 2, then it's just 0 divided by 0 is 0.
So you're doing this. The only thing you know for sure is at the end, there's going to be no remainder. That's all you know. You don't know what this quadratic is. There are other ways of finding it, like you did for homework. You could do x minus 2 times this is equal to x cubed minus 2x squared minus 3x plus 6. And then you set up your, okay, this has to be x. This has to be negative 3, I think. What's the middle term?
Aren't we dividing by 0, so why does it work?
Yeah, you're not dividing by 0, you're dividing by x minus 2. You just know that there will be no remainder, which is perfect because it fits in perfectly. As in 3 fits into 6 twice with no remainder. 3 is a factor of 6. So you're looking for this. You can use this method or just long division. Richmond, you got it ready?
Oh wait, do we have to do?
Yeah.
I know. I was just saying. Wait, it's just.
Wait.
Wait.
The full factorized.
Wait, what?
What?
Just x squared minus 3. It is. Oh, that's it. What? It felt so weird because that was too easy.
Oh, was it?
I mean,
Too easy for Alex.
no, I mean
Too
like.
easy.
No, I mean like.
Alex,
This was too easy. Alex is.
You didn't fully factorize yet, though.
Yeah,
Is
fully
it
factorized.
x minus 2, x plus 3, x minus 3?
Shebang.
So there's the 3, yeah. There should be 3 factors.
Yeah.
Are you
Including the x plus
Is he filming?
2.
So we get this. This is weird. Okay, there's no remainder, so we got a no remainder here, so we got to bring down this next. So there was a 0 here. You can put it in, but we bring down this next. So just minus 3. So you just end up with minus 3. Then you multiply it by that, and you get minus 3x, and it's plus 6. It's 0. So that's all we have. There's no. C turns out to be 0 here.
Well, that's annoying.
Do you want me to do that slower? They cancelled out, so we brought down both these next, just to have 2 terms to divide this into. Yeah. Okay, so we have this. We know that x minus 2 times x squared minus 3 gives all of this. It's not fully factorized, though. I have to factorize this quadratic. What is it factorized? How do I get? Plus root 3, isn't it? And x minus root 3, which you could got by just solving this equal to 0. X squared is equal to 3, x is equal to plus or minus root 3. So there's the 2.
I got that. Good job, Alex.
Okay, so the question is, what is the factor theorem? What is the remainder theorem? You already know them. This is the technical way of writing it.
I don't like the tech.
Yeah, I know. But we have an example to go off. When a polynomial is divided by something, x plus or minus something, until a remainder is obtained, then the remainder will equal, if you just subbed, I removed it, if you just subbed in x equal to minus 2. If you sub in x, so they use k, but it's the same thing. This, if you sub in this, you get this. That's the remainder theorem. If you sub in, it's not a 0 because it doesn't equal 0, it equals the remainder, what's left over, how far it is off 0.
So the number used to make it 0. Oh, I see. So
Yeah, 'cause it doesn't-
The remainder is just the y crossing.
Yeah.
Yeah.
If you want to think about it that way, yeah. When x is this. It's actually a point.
Yeah.
It's not, would it be the y crossing point though?
Yeah.
Because x is minus 2.
Is the remainder the constant? No,
X would have to be 0 for the y crossing. When you do the zeros, that's where it crosses the x-axis. This one still crosses the y-axis at minus 4.
Oh, yeah.
Yeah, so you're finding the x crossing points. But it doesn't. The x-axis crossing points when y is 0.
Wait, what do you think is the constant? Like what actually is it?
Yes, I can, yeah.
Can you
I
try
got-
to use English?
I'm going to use it, yeah, I'm going to say it again. So, if we get a polynomial, so any polynomial, let's just write another one, x cubed plus 2x squared plus 3x minus 7. That's a polynomial in x. If we divide it by something, let's say x minus 2. Oh, let's use a different number because we already, x minus 4. Let's say we want to divide that by that. Yes? But let's say we just want the remainder. We just want to see what's left over if we divide that by that. To find the remainder, sub in x equal to 4.
What if you want to do?
And you will get the remainder.
What if you want to do x minus 4 divided by x cubed plus 2x squared plus 3x minus 7?
If you divide this in, you will get the remainder. It'll just take longer. That's the very first thing we did. It takes a long time to get the remainder because you got to do multiple steps.
I'm saying, what if you want to get the remainder of x minus 4 divided by that?
Oh, you want to divide this into this?
Yeah.
Oh, you're going to be dealing with negative powers. So yeah, we don't want to do that. Okay. So that's the remainder theorem. It would maybe a more... Well, this is what I kind of do. If you have a polynomial, some x cubed or x to the power 4 thing, and you want to divide it by something, but you just want to find the remainder, you don't want to divide this and do all of this work to get just this number. Instead, I could have just subbed in 4, the opposite sign to in here, and I will get the remainder. I will get this number, what's left over when I divide by. That's the remainder theorem. Sub in is the remainder too. Sub in x equals something. Okay? So the opposite case then is kind of the factor theorem, not the opposite case, but if we know that something is subbed in and will equal 0, then that thing is both a 0 and a factor, which you kind of already know anyway from your quadratics. If we have a quadratic, the very last thing you do is called the null factor law, which is directly linked to this. Yeah, when you get this, when you solve it, you get x equal to -2. That means if x equals -2 gives 0 when I sub it in, that means that, -3 here. Yeah. These are both then zeros,